my name is Aneri Pradhan, and I'm partner of Climatic Group and co-host of Climatic Scale, where we focus on telling stories of climate solutions that are scaling. Today, I'm joined by Andreas Mitnick, who is the founder of Strong by Form, a company developing bio-based ultra-strong materials inspired by nature, with applications in construction and beyond. We'll talk about what it really takes to scale a deep tech materials company. Welcome, Andreas.
Hey, Nori, thank you so much for the invitation.
Of course. Very excited to talk to you. So tell me your founder story. What drew you to materials, and when did you realize that this is a great commercial opportunity?
Totally. I became a founder not because I was an inventor. Actually, like my co-founders are the ones who invented the technology. But I kind of passed in doing corporate venturing, meaning connecting startups with large corporates and help those startups to grow. And that helped me to understand how you transform actually a technology into a business. And that's the bridge that I wanted to play. And I was lucky enough to have two brilliant co-founders that decided that it was possible to invent 3D wood that would be ultra light and ultra strong and could be manufactured at a massive scale. But they needed someone that was able to transform this into a business. And I have reached a point in my life where I really want to have my own project. So everything like stars came together and we started Strong by Form. But I would say that the original idea of Strong by Form, or what we had in the back of our minds, was to help decarbonize the built environment. We weren't sure if that meant construction, if that meant mobility, if that meant consumer applications or industrial design. But we knew we wanted to be in the hardware space, meaning we wanted to take carbon or provide an alternative to carbon-intensive materials. And that was when we were discussing how to do that. At some point, my contribution to the team was, okay, that's great. But if we want to do that, we need a company that is able to have a global scale. And that means having a huge company, and that means that this needs to become a huge business. Even though you might have not thought about this as a business initially, but more as a technology, if we don't have a very sound business proposal, we'll never get to the scale that we need. And there we coined our vision where we play with money and we use a lot of funding and a lot of money, and numbers are big, but money is way on how to get to the final goal, which is help decarbonize the built environment. And we still stand there, but that framework has been very useful, especially in the last year or so, where I would say that the appetite for climate has come down since before. But because we had already focused on being not only green, but very competitive on price and understanding that if we want to push a change, we need to offer someone something that is better and cheaper. That helped us navigate that. And now we're in a position where we really have something that can compete with concrete and at scale could definitely help decarbonize construction.
That's super, super interesting. And what do you think is fundamentally broken about today's structural materials ecosystem? You just mentioned competing with concrete. What is the challenge?
I would say that what's broken today is that as a civilization, we got lazy. When you look at the Gothic cathedrals, those are very sophisticated structures. And everything they do is 3D. They have arches, they play with shapes, because for them, moving stones and lifting stones was hard, wasn't easy. And it's very impressive that when you go to a country like Germany, you see a church that is 1,200 years old and is pretty tall, amazingly tall. And the only way they could do that was using a lot of brain power to make it as light as and efficient as possible. But then years went by, and we humans made a wonderful discovery: the steam machine, and then the oil. And suddenly we had a lot of strength that didn't come from our bodies or the limitations of biology, but we had the power of oil and the power and the energy. And that wind down the restriction regarding how much can we move around. Moving heavy stuff around and playing with heavy stuff became simpler. And that's what concrete is about. Concrete can be done in a 3D way and can be much more efficient. But the way we use it is like we came back to the Egyptians. So we came back to say, okay, more strength, more mass, because it's not such a problem moving the mass. It's more of a problem thinking, how are we going to do something that is 3D? And it's simpler to do 2D things than 3D things. And if we can move 2D things, and if moving a lot of material and placing it somewhere isn't such a big problem, we decided to start building 3D structures using 2D shapes. And that's not efficient. That can be cheap, especially if energy is cheap. But the abundance of energy had made construction very lazy on how it uses the materials and very inefficient in how it uses the materials. And I think that we got addicted to oil for mobility, the same happened in construction. The thing is that it's less obvious, but we are very inefficient. We pour material into stuff just because that is easier than think on how to be more efficient.
Oh, that's so interesting. I love the energy tied to it as well, because sometimes people think of construction and real estate as not really an energy focus, but it actually very much is. And I also like that you talk about taking inspiration from ancient architecture, because I also feel that way too when I see, for example, ancient temples in India, and I'm just like, wow, what happened to the beauty of the built environment that mankind was so good at so long ago? Why are conventional materials like steel, concrete, and aluminum so hard to replace?
This happens a lot in the built environment. And we work with a combination of wood and adhesive, so chemistry also plays a role here. And I would add to your question, why are we still working with chemistry that comes from the oil and not from more natural? And the answer to all of those is there's a lot of experience. As humanity, we have 150 years of experience working with steel, working with concrete, and working with chemistry that comes from the oil sector. And that is a lot of knowledge. And that is a lot of sophistication. And we do things in a way better than we did it before, even though it's still polluting and there's so much room to improve. But from a productive perspective, for example, in mining, to make it more productive, they have built bigger machines. So yeah, the scale has to make it more productive so it's cheaper. And then trying to bring to the market something that it needs to be competitive in productivity and in price with something that has 100 or 150 years of knowledge around how to make it cheaper, it's a huge feat and it's highly complex. And that's why it's so hard to push green technologies, especially the ones related to the built environment, because it's very hard from day one to catch up to 100 and 150 years of knowledge. And these guys are good. They know what they're doing. They're very efficient at how they build. And there's a lot of conversations around the lobbies of the industry. And of course that happens. But I think that more important than the lobby is actually that these corporations and these industries have done a good job, and they actually have put an entry barrier that is hard to beat us on price. And then price is spread, trickles down everywhere, because if I'm going to buy in my apartment, I would love to have the most sustainable apartment, but I have a budget, and that would always be in conflict. So you need to consider the business. And I think that more than the technology, because the technologies, I would say there are many technologies out there that from the technical perspective could replace many materials. It's basically the productivity and the advantage that current materials still have regarding all the knowledge in how to produce them, the distribution networks, and the experience of the final users, meaning architects, engineers, and construction companies, on how to use them, that play a huge barrier for companies like ours that are trying to actually create a change.
And tell me more about your technology. How does Strong by Form's Woodflow technology work, and for the general audience?
Absolutely. And one of the reasons that I would say one of the technologies that have a chance to actually create the change is because we think about sustainability in the beginning of when we started the company in three ways. The first driver of sustainability for us is efficiency in material consumption. So whether you're working with concrete, steel, wood composites, if you're using less, it's better. So we are very, very focused on using as little material as possible, because that's, in our view, the main driver of sustainability. The second one is to be able to reuse it. And the third one is to be able to recycle it. But in our case, recycling comes after 200 fibers. And our drive to be efficient in the material consumption is that philosophy is what has actually nurtured the company. So what we do is that we have devised a way in how to use wood without modifying it, but in a process, in how to process it, so we can create 3D wood. And 3D shapes are interesting because they structure themselves. So you can add a lot of stiffness by adding a shape to something without needing to add more mass. The best example is a dome in let's say, the Vatican, which is a very long, it covers a very long span without any columns in a very efficient manner. So 3D is a key driver for us. And I honestly, I don't know any other company that can do 3D wood in a additive manufacturing manner. The second one is that we, inspired by trees and how they structure themselves, we realized that a tree has all its fibers aligned following the stress map. That means, in simple, that all the wood fibers are serving a structural purpose, and basically there's no filling material. And we copy that from the tree, and we align the fibers within our products to map the stresses, the flow of the stresses. And that's a second layer of optimization that allows us to make things light and strong. And from there onwards, of course, we have to develop a manufacturing process. For some use cases, we use robotics. For others, we use more conventional machinery. But that also forced us to develop this manufacturing process because no one worked with wood the way we work with wood. But at the end of the day, what we have developed is a wood composite material that, by having a specific shape and a specific fiber architecture, can compete with concrete and steel on strength at a fraction of its weight. And because it's light, it can compete in price because the material consumption is very low.
Nice. You just answered my next question. That's great. So tell me about your first commercial pilot. When was it? Who was it with? And what were your outcomes?
That's a very good question. Actually, I would say that our first commercial pilot was a project we did with Deutsche Bahn. Because when you're working with structural materials, there are a lot of considerations that you need to take into account. First of all, there's a long process. Not only the development of the technology takes time, but then you need to go through certifications, then you need to enter the market, gain the trust, etc., etc. So we, as other companies in our space have done, we decided that our first sort of product would be more of an architectural product because entry barriers are way lower. And we were developing that when we applied for an open innovation challenge with Deutsche Bahn. That was about how to make their infrastructure greener. So we came there and we told them, like, hey, we have a technology that is going to be able to showcase that, like, you are very forward looking because we can cover one of your stations in a very nice 3D wood, like cladding, and it's going to be amazing. And you're going to be able to convey the message that you are working on sustainability because you might do a lot of efforts, but sometimes people don't see them. This is what's going to be very visual and very expressive. They look at us, they told us, like, that's great, we're going to work with you. So we were selected for the challenge. But then they told us, like we are not going to buy that. we want something that is really meaningful. And something meaningful for us has to do with structural performance. And that's why we selected you. So why don't we create something structural? So actually, we leapfrog very quickly to our first pilot, instead of being a decorative one, being actually a structural one. And that was super cool because we were able to test different sort of versions of our technology and help us also understand what part of it we wanted to scale and what, like, use cases we didn't want to scale. At the end of the day, making the story shorter, we created a weather cabin. This is, of course, like the typical structure where you would stand like a shelter, where you would stand when the weather is not great, entirely made out of our material. It's almost 100% made out of wood. Even the connections between the beams are a version of our technology, which we call Woodflow joints, which is something that we decided to leave for a later stage because they were very hard to manufacture. But they're there, and we tested them. And that was a pretty neat pilot because when you work with a company with Deutsche Bahn, it's, of course, today you can go to Berlin Südkreuz. The weather shelter is there. You can see it. It's very unique. But you're going to notice it if you're around Südkreuz. But what was the biggest, I would say, milestone for us was not only having the shelter there, but placing something in ground owned by Deutsche Bahn. Because the level of testing that you need to do, the level of confidence that you need to gain. Like, this is a public German company. That's synonym to a lot of bureaucracy, a lot of risk adversity. So they won't take a risk and not even and place it for public use, right? If that collapses, like someone will run into trouble, us for sure, but them as well. So for us, that was a huge sort of demonstration that we make a sale, because that was a paid project, something that really pushed our technology to the limit in those days. Actually, it was so big that we couldn't even test the assembly here in our shop. But we were also able to demonstrate that we can comply with the highest standards. And that was really like a game changer here as from Reform, and opened the doors for others to actually be willing to work with us, because of the trust is transitive when you're an early stage startup. So you are as trusted as the guy who trusts you before. And that's why that pilot was super relevant for us.
Yeah, but that's such a cool story. And I feel like a lot of our startup audience listeners are going to be very inspired by that. And also, you applied for an open innovation challenge and it resulted in something very powerful and meaningful for your first project, which is sometimes I think startups think about, is it worth applying? This is going to be very competitive. But then in these cases, it can be very transformational. And I'm definitely going to look for this when I'm at Südkreuz next, because I can imagine it's probably very striking. I can't wait to see it.
It is just a last anecdote there. I think that it's interesting what you say is if it worth the effort for the open innovation challenges. We have applied to many and they have opened many doors to us. We work with very large corporations. We work with BMW. We work with Dassault Systems. We work with Deutsche Bahn. We work with NS. We work with Siemens, Alstom. I think most of them have come through open innovation challenges that we have actually. And if you're a startup, you need to compete. Like, you need to prove yourself, because the market is even harder. Like, when you're out there in the market, that's where the shark is. At least in the open innovation challenge, people want to collaborate with you. And you know where they start, you don't know where they end. So the weather shelter that we created was supposed to be exhibited for 2 weeks at Südkreuz. And it has been more than a year now, and it's still standing there. Because the station manager and the guys from Deutsche Bahn are really fell in love with it. And of course, it's amazing promotion for us.
Yeah. So what would it take for Deutsche Bahn to, if they love it, right? Why not just put that at all their stations? What would that take?
That would take for us to be able to manufacture that in an efficient manner. Because that was a one-timer. And we also learned about that. We also learned what is a one-timer. And we also learned that we don't want to push forward an agenda on one-timers and that we need to scale the product. But that work, in combination with what we've done with BMW, opened the door for the railway sector. And then we got the attention from a company like NS, which is the Deutsche Bahn from the Netherlands. And now we have a full agenda in railway, not in the object that we created for Deutsche Bahn, but in train interiors. But again, you know where the things start, but you don't know where they ended. So even though there was a one-timer that won't be replicated, Strong Reform is very present in railway, and hopefully in the future will be highly present in trains. Didn't end up there. It was simply the gate opener for the industry.
Got it. Yeah, that's great. So you mentioned a little bit about like the concern about the risk of having a public installation. In built environment, certification standards are like a very essential part. How do you navigate that as a startup, and what slows things down for you?
Yeah, that's basically it's a complex environment, and and this is a bit technical, but for things that exist, they're like homolog techniques, or however you say that in English. Apologies if that's not the right word. But let's say there's established process, an established set of tests. If you comply with A, B, and C, you can do it. For things that are new, you need to propose it. And then the testing needs to be evaluated if it's proper or not. And then the material or the element needs to go through a number of test processings and committees that will actually tell you if you're working on the right place or not. And what makes it even more challenging is that you do not only need to certify the product, but also the manufacturing process, because you need to be able to show that your output is reliable and quality is stable. So that poses 2 different types of challenges. First, how to do the certification as quickly as possible. And secondly, how do you put together the infrastructure required to get the certification before coming to the market, because you cannot come to the market with something that hasn't complied. For the first part, how to speed up the process of certification. Honestly, that's a lot of work and you need to talk to a lot of people and a lot of experts. We were facing certification times of 4 to 6 years. And there's a lot of like these terrible war stories of people that have mostly coming from academia though, but like new developments that look like great business, great technical opportunities, but they take so long to certify that they don't, and they run out of funding like during certification process, and then they're supposed to be ready, and there's one more thing, etc., etc. So what we did was that we listened to all this. We always were convinced that we would be able to find a solution to this. But as we learned more and more about the process, we understood that certification can also be a step-by-step process. So you don't need the full certification in the beginning, but you can start by certifying parts. You can start by certifying formulations. You can do that in a step process. And also previous certifications can also provide a stepping stone on how to certificate yourself. So at the end, we settled on hiring an expert in certification from the south of Germany. And this person looked at all the previous certifications that have been achieved. In this case, it's a hollow core, which is basically a slab that is hollow in the middle just to make it lighter. And he found one that somehow resembles to ours. And we can say that we are doing an improvement over an existing certification instead of a full-fledged certification. And that reduced the certification period to 1 to 2 years. And that's something that we can manage. And then we had to validate that. It was too good to be true. So then we went to another research center and we told them like, hey, we have this data. Do you agree that this can be done? And they also validated it. And we were applying to our grant, so they were taking it seriously. So now we're very confident. But honestly, we talked to many consultants. We spent a few years until we were able to find a way how to address it. But now that we know, I would advise anyone that is in this space, find someone that really knows and pay for a report to find the way to do it, because it's too complex to solve it yourself. ChatGPT doesn't solve it. And then the other part, building the infrastructure for a product that is sold in the market, we are solving that. We're fundraising right now. Honestly, it's not easy, but the way we're doing that is by having this dual strategy, having a product in the market that it's early, that doesn't have this certification burden. So we're creating some cash flow there. We're creating market traction. We're building a brand. We're making the contacts, and we are basically arguing, hey, we already put a facility together. We develop a product. We have the product in the market. The product is selling. We're going to repeat again with a more complex product and a more complex facility, but we're not newcomers to this. We already did it once. We're simply paying again something that we already did, and we are gaining confidence from investors like on that side, not knowing that we have already demonstrated that we can do what we say that we are going to do. And we'll see how that comes, but I'm confident that will end up happening.
Yeah, you just shared so much wisdom and nuggets for, I'm coaching some innovators who are navigating this certification question at their universities. And so I'm definitely going to share this podcast with them and the Be Visionaries program, because I think there's a lot of wisdom in what you just said. So how does the capital intensity and long sales cycles affect your scaling strategy?
That's a very good question. And that doesn't work. If you want to go the VC way and you want to be a startup and you really are trying to grow at a fast pace, it's hard to be capital intensive. Now, let me get the opportunity to say that AI is the most capital intensive industry that exists. So all that conversation about startups not being capital intensive, honestly, is from the past. It's really from the past, like when this was software, but software is done. Like you won't find big returns of software because it's too easy now. So you need to go, and AI is the best example of a very capital intensive industry that all VCs want to invest in. So that shouldn't be a constraint, but it still is, because in the mind of many investors, startups cannot be capital intensive. And you need to live with that. I'm not in the business of changing investors' minds. I'm in the business of creating something that investors can actually feel that they would do a good investment on it. So we are in a capital intensive industry because we need to build factories. We need to have working capital and stuff like that. But that doesn't mean that the CapEx needs to come from us. This is what we have found out. CapEx is something that is available in the world in a very abundant manner. Every corporation is very used to invest in CapEx. Every manufacturer is very used to invest in CapEx. And I see that from my corporate investors that actually tell me like, hey, participating in your funding round, for us is hard. We're going to make a bet on a startup where the outcome is not so clear. If you come and tell me like, hey, I need 10 million euros to put together a plant, and you show me the machines and the warehouse that you want to build, that's easy for us. We know how to address that. And they're always growing, and like technologies become outdated, and they need to buy a new piece of equipment. So CapEx is a very regular part of a very large part of the industries. So what we do is that we're not in that part of the business. So our focus is developing technologies and become a technology provider. So we basically want to grow with the industry. We want to do joint ventures where we put the technology and a partner put the CapEx, and then they run the facility and they manufacture and they know how to do that. And in that way, we can have different industrial partners in different parts of the world, and we can actually grow fast at a low CapEx. Of course, we need some CapEx, right? We're raising 10 million now. We're going to be raising probably 30 million in a few years. But that's where we go. It's not like we're going to need 150 million. Our CapEx investments are bounded, I would say, are unlimited. And then CapEx comes from others. It's not that it doesn't come, but it doesn't come from VC, which is where you won't find money for CapEx. And then also, we are working with the industry in the sense that for construction in particular, we do not want construction companies to be our client, but we want to be one step behind. We want to sell to people that sell to construction projects. So we realize that every construction project has a lot of like singularities. So we are entering into multiple construction projects. Many startups have failed already following that strategy because there's too much uncertainty to be handled. So we want to sell nails to people that make furniture. That's our strategy. We want to step one step behind, sell something that is more of a commodity that adds value to others, and then go and do the final sale.
Okay, this is a really great scale strategy. Thank you for sharing that, especially the visual of the nails to furniture, because that really explains like how you can be in so many countries with a physical product like this. That's requires manufacturing. What are your top priorities for the next 12 to 24 months?
We need to close our funding round. We are currently raising a 10 million round that we expect to close in a few months. And then the top priorities are putting together the pilot plant, get the certification, and increase the sales of our product that is what's called Woodflow-skin, which is in the market, and actually try to do partnerships to scale manufacturing the same manner that I described before for this other product. Those are our priorities, like more revenue, the infrastructure we need to certify, then the certification.
Nice. And if you could change one thing about how industry approaches innovation and materials, what would it be?
I would love that someone actually is willing to be the first one to test. Like, I wish that the industry was more open to actually testing, because it's very hard to get a test. It's very complicated. And I understand why, but there are testing grounds. Like, I feel like when you come to materials, innovation is a great word and people like to see it in a PowerPoint. But when it comes to applications and real applications, there are few that actually take the risk. Deutsche Bahn, for example, was a great example. But it's very hard to find those matches. I would definitely try to work with companies to be willing to be the first one to test and not try to sit on the side and wait for someone else to test it.
Oh, it's so interesting you say that, because I feel like I've heard that across the climate tech industry is the lack of risk taking and innovation as like a brand and not in practice. I totally agree with you. And that I had a question earlier, maybe we can answer that, is how do we convince them? How do we convince these conservative industrial players to try new innovations like Strong by Form or Woodflow?
I think that there are two angles there, at least what has worked with us. First, give them something that makes business sense, like present something that actually is appealing to them from a business perspective. And then be as sexy as possible. I create and have an aura of hype, convince them that it's cool to test with you. And that might sound vain, but in our experience, that is super relevant, that people like what they're doing. Like, we work with BMW and the team tells us like, hey, this is the coolest project we're working on. And that's huge. That's huge because you see their time, you see their commitment, and you see their willingness to test. So doing something that is innovative and that they could really like, and that's also very relevant. And that's not only about the looks, but also how you approach the technology development, how much you involve them into the process. It's not about getting getting into a meeting, get the client requirements, get into your little black box, and then meet them again with the final product. And this is a lot about engaging with them and trying to like showing like small advances and ask them like, what are you feeling? Like, is this the right way we're going? That was the same too with Deutsche Bahn, engaging with other people also. We were like, so we did this weather cabin. Perfect. And then we were like, hey guys, why don't we do an opening? And why don't you bring like your boss and your boss to this opening? We ended up having Deutsche Bahn's CTO at the opening, which was huge. And it was huge for everyone within Deutsche Bahn that was participating in the project. That hype and that engagement is really key to make these things happen.
Oh my gosh, that's such a great insight and advice to end our conversation on. Thank you so much, Andreas. This was a really fun conversation. For our listeners, you're listening to Climatic Scale, a podcast about what it takes to truly scale climate technologies innovations. You can find us on Substack at climaticgroup.substack.com, Apple Podcasts, and Spotify. Thanks again, Andreas.
My pleasure, Harry. It's been a super pleasure.